you turn on the machine 20 minutes before using, and that's with the button just above the cables at the back there. And then once that's done and it's reached 20 minutes, you can open the Mastersizer program, which is just there. And following the SOP created on the document, you can go to New and create a new measurement file, and you can name it depending on the sample you're using. So in this case we can put test Mayo, and then we can save it under the file which you've created for yourself under the DPSU document file. So we'll create a new one now and put Mayo. Alright, so we can save it here. Once it's saved, it should create a new tab here for yourself, so then you can take the readings all along down the document. So once that's done, the first time someone uses it, they should go to manual measurement and then go through the list, filling all the details required for your sample to take a reading. So first of all, just label it. We'll call it bioactive glass. The particle type, unless you know it's spherical, I would put non-spherical. The material, there's a list that you can choose from if you don't know your refractive index, for example. So you can go to browse database and you've got a whole list of materials with their refractive index. So for example, in this case we can go to bioactive glass. There should be something. We need something similar with a refractive index close to glass, which is 1.5. I would just use borosilicate glass, please, that's fine. 1.51. Dispersant, generally you would use water, unless you want to use something else such as ethanol to help with the dispersion, or whether your material dissolves in water. Instructions, you can leave that blank. Duration, this should remain the same for the water system. So it's 15 seconds for the background measurements, 10 seconds for the sample measurements. Sequence, the number of measurements should be a minimum of 3, so we've put 5 here. Alarm, you don't need that. Accessories, stirrer speed, we should leave at 2000 and keep it the same every time we make a measurement. So for example, if you have 10 samples, keep it the same. And you don't need any ultrasound unless your sample does clump together, and then you can use that to break it down. So you can just turn it on depending on what you need. And you can also do that manually, which I'll show you later. Cleaning, we'll prefer to do the cleaning manually ourselves, which again I'll show you later on. Analysis, to start off with, unless you know that you have 2 narrow peaks, for example, then I would use general purpose. But then after you've got your results, you can still go back to this and edit and change it to a different one, depending on how good your results are. Yeah, you can leave everything else the same and just press OK. So it'll bring up this screen here, and then we can do the cleaning from this one. So we click this button here, so it's the Hydro EV, which is right there, and this brings up another screen where you can control the stirrer speed, and you can also control the ultrasound, so you can turn it on and off using the button here, and you can control the speed. So for the cleaning, we would prefer to use something close to about 3000, just above 3000, anywhere above that, and leave it on for 5 to 10 seconds every time you replace the water in here. So this is the Hydro EV system where you would place your sample into once it's in solution. So this you can just lift up, you can remove that, change the solution, add the ionized water, then set that up again, and then you can just give it a quick clean. So you put that on and it should start stirring to that stirrer speed. Yep. So then just turn it off. So you would do this about 3 times. So once it's done, for example, we've done it 3 times, then return it to 2000 for your sample measurement speed. Then you can close that once the cleaning is done. Once that's done, you would have to press start, which would bring you along the tabs here. So every time you want to jump from one to the other, you just press the start button. So start to begin the measurement. The system will start aligning. Shouldn't take too long. Look, the aligning is complete. But we can see here, this shows us that the system's not clean properly, because this should be more of a curve like that. We shouldn't have this peak here. So we should do more cleaning cycles until this is a curve like that. But for demonstration, we'll just keep it like that. Then you need to make a measurement, a background measurement. So then you press start again, as we mentioned. So you press.
Okay, we're running.
Great. Okay, so once the measurement background's done, and then it will move to the next tab, which instructs you to add the sample until the obscuration is in range. So the range we've put in is 5 to 15%. So if anything between that would be okay to make a measurement. But try stick to the same obscuration throughout your experiment. So if you're doing 10%, then keep on using 10% for your next samples, just to keep things standard. So we've got the sample made here. So we've got the bioactive glass powder, and we've put it into a solution here, and we can use a pipette to pour, or we can just pour some of this, some of the sample in directly into the beaker. And as you can see, the obscuration goes up gradually. So we control the obscuration. So now we can add some more, get it close to 10%. So slightly bit more. Yeah, that should be fine. So just get it as close to the required obscuration. And then once that's done, you can just press start and it'll make a reading for you. And it will take 5 readings for us as we asked it to do so. You can pause it. So. Yeah, so it'll do that 5 times. Then once that's done, it will gradually add it to the list at the back here. So it's added 2 at the moment. And we can see that the stirrer speed is at 2000 for the tab here. So this is the last one now. So that's it, the reading's done. You can stop that. Just minimize that. And you can go to your results here. So we can see we've got 5 and we've got the D10, D50 and D90. However, another important thing is the weighted residual. So if we have this low, we would prefer to have it below 1%. So this shows how good your data is. If it's anything above 1%, I would recommend doing it again and adjusting the obscuration range. So just try doing it at different range, higher or lower, and that will change the residue. So to analyze the sample, we can select all of them, and under reports we can see that this is the results that we have under results overlay or analysis. So this will show the same thing in both tabs. So we can see again it shows us the D10, D50 and D90, which is most important. So the D50 is about 16 microns. I believe this has been sieved with a 38 micron sieve, so it's below 38, and 50% less than 50% of the particles are at 16.4 microns. Yeah. And under fit, for example, we should have these two lines. So if we just select one of them, under reports and fit, we should have a green line and a blue line which should be aligned with each other, or one should be lower than the other. So the red line should be joint or above the green line to show that your results are significant and it's made an accurate reading of your samples. If this is not the case, then you can adjust, you can do the experiment again, adjusting the obscuration. Yeah. Yeah. So once you have your readings taken by the particle size analyzer, you would need to export your files. So you can export it to your computer and use it with Excel or anything else, any other program that you prefer. So select under reading, and then you can go to report, and you can take the raw data from clicking this button just here, so export content, and then you can either copy as an image or copy the raw data. I would copy the raw data, and then I would paste it and save it onto a notepad, which you can open later at your computer. So then if you want to draw a graph of the exact same thing in Excel, you can just copy and paste this into it. So you can just save that into the same folder that you created earlier. So bioactive glass, you can save that, should be fine. Then you can also save this directly as an image if you don't want to draw up the data in Excel. So just copy it as image, and you can just paste it into Paint or anything you prefer. I would suggest using Paint. So you can just save that too. So save this file, then you can copy this into your document or into your thesis. Another, the machine, if you want the machine to analyze the data for you, including standard deviations, it would under trend, you can get this table here, which gives you the D10, D50 and D90, including the means of the 5 readings, the standard deviations. Yeah. So you can also copy that directly as done so before. So just copy raw data into a notepad and save. Okay, so before you make a measurement, you need to clean the air system. So you can just you can remove the tray by loosening this. So you just twist that and you can remove the whole tray. So this needs the clean, so you can see there's some powder in it. So you can remove this again, remove it completely, and just use some ethanol and some tissue just to give it a clean. Yes, we wouldn't need much anyways. So once you've given it a clean, put it back into the sort of hooks on and lock it back in place. It should be good. Then you put this back on the barrier, which you can control. So put it back to where it was before, as we mentioned. So once that's done, you can add your sample to the tray. If you're doing this the first time, then add a bit more, because you need it to last for the 60 seconds of the readings that it's taking. So now you can just close it. Should be ready to take a reading. Then you go back to the program, and then you need to open, as we did so in the water system, to control it manually. Again, go into this button here. Now it just says Aero M. It opens up the controls for the airflow, so the air pressure, and the feed rate, which you can adjust during the measurement. So before that's on, you just put that back. And it will give you instructions of what to do here. So ensure the sample tray contains the sample, as we did so, and enable the airflow before pressing start. So the airflow can be controlled by the other window here. So you just put that on, and we've got it at 2 bar at the moment. Which shows the air pressure is up to 2, and if you want to adjust the air pressure, don't adjust it all at once, adjust it in small increments so you don't damage the machine. So then you can just press start and it aligns the system. Measure the background as we did so with the water system. You just follow the tab along. Enable airflow and then press start to measure the background. So you just press start again and measure the background now. And we've asked it to make it background measurement for 30 seconds and an actual reading for 1 minute. So the compressor will go on from time to time to keep the pressure at 2. Once the measurement background is completed, it will ask you to press start and then enable the feed. So the feed is what controls how the speed of the powder being added to the actual machine. So press start and then press start and then press feed automatically. And then keep an eye on the powder as it goes in. That the obturation range is above the 0.1%. So it's taking a reading, and if we look, there's enough powder which should last for 60 seconds. If it's your first time, you can always change the rate by adjusting the typical barrier or adjusting the feed rate by changing the percentage here. So that just percentage controls the vibration rate of the tray. So if you increase it to 90% or 100, then it's going to increase the speed. And the air pressure, depending on how hard your particles are, how fragile they are, if you have a higher air pressure, it breaks them down more readily. You can increase that, you can give it a few goes, try at 2, 3, 4 for example, and see whether the particle size changes. So do we still have more powder in there? So it should last enough for the 60 seconds taking a reading. So once that's done, you can turn it off yourself manually by just pressing standby. Yep, so that's all complete. And you should have your results in the background here. So we can stop that and minimize it. So you should have your results here, which should be quite close to the water system. Yeah. Okay. So for the air system, you would have to create a measurement file the same as we've done before with the water system. But now you need to change the cell, which is just here, and it's connected to this where you had the sample. So you click this button here, and it sort of automatically comes out. So we can remove this. But in general, we'll leave the water system in use because more people use the water system here. So we'll just put this to the side while we plug in the other system. So you can just push it down here. So it should be fine to leave there. And now we can connect the air system, which is here, to the cell, which is in this box right here. So it's similar to the water system. You can just place it straight in. And you'll pull it in by itself. Once that's done, then connect the pipe to the cell, which is, you just push it in and twist, and it locks it in place. Okay. And then this is all connected to a compressor to create a vacuum, and it's created to the vacuum here to remove your sample. So your sample, you won't be able to retrieve your sample because you'll go directly into the vacuum. Okay. So that's up and running. And we turn on the compressor using this button here, and we open the air valve. If we've got, I think we should have power. So we turn it to about 4 bar because that's the maximum. So we turn it to about 4 because that's the maximum that the machine can go up to. So depending on what you need. Then again you go to measurement, to manual measurement, and you do the same procedure as before with the water system. So you would name it. So we'll do the bioactive glass again. Just misspelled that. Non-spherical material, just keep that the same. Duration, the duration changes here because instead of making 5 measurements as it does so in the water system, this would just make 1 across more length periods of time. So for example 60 seconds, but for the background measurement it's for 30 seconds. So you need enough sample in the machine so it gradually puts the powder directly into the machine from here for the next 60 seconds, so you would have to fill that quite a bit. So number of measurements 1, so just take one measurement, then you can do that multiple number of times. Obscuration, we need it at a lower level, so we need it at 0.1% because the powder is added gradually and it sort of fluctuates, so as the powder goes in, the bar would become green, and when there's no powder it would just stop. So it's not as continuous as in the water system where it keeps a stable obscuration. So that's why we need the lower limit of 0.1%. The bar again, like in the water system, you should keep it the same as in all sample measurements. So we can keep it. We can start sort of about 2 bar, and the feed rate is the rate at which the machine puts the sample in. So the rate at which it vibrates. If you increase that, it will shake the tray more, and more sample would go in. Another way you can control the amount of powder which goes in is by using this physical barrier, which you can just loosen. You can loosen and move it up or down, which creates a space here. But you would leave that quite low, so almost right at the bottom, because you want it to gradually feed your powder into the system. You don't want it all at once. So you want it over those 60 seconds to feed it in. So once your feed rate, leave it at 50%, then you can increase it gradually. Analysis, leave it general purpose as it's done so in the water system before. You can change that later on. Keep everything else the same and press OK. Yeah.